Hi, I'm Peter, and today we're going to talk about the work we did on Zamba Cloud, DrivenData's tool for training custom AI for species identification from camera traps without having to write any code. This work was generously sponsored by the WILDLABS Awards 2024 in partnership with ARM. DrivenData is a social enterprise focused on data science with social impact. We do a combination of machine learning competitions, direct consulting, and open source projects. This WILDLABS Awards project aimed to bridge the gap between technical feasibility of machine learning models and practical ability of conservationists to use them. Camera traps are widely used to monitor wildlife, generating thousands of images and videos that need to be reviewed and labeled manually. While machine learning models have shown real success in classifying species present in an image or video, which can save countless hours of human review, they don't exist for every species or habitat of interest. Zamba Cloud aims to provide an easy way to train custom species classification models and use these models to process images without writing any code. A number of folks from our team worked on this grant, including myself, Emily Dorne, Jay Chi, two of our lead data scientists, and Justin Chung Clark, a data scientist. In this work, we set out to add support for camera trap images in addition to videos. The work here fell into 6 buckets. Gathering many labeled camera trap image datasets to use as a model training dataset, conducting experiments to pin down different aspects of our model training procedure, training a broad base model on a large number of taxa, understanding user needs by surveying our community and the WILDLABS users, integrating the new model into our existing tools, and doing user testing and feedback. On the data front, we used Lila.Science datasets and brought in 20 labeled camera trap image datasets from around the world, with more than 7 million images. We cropped all the individual animals from these images using the annotations provided by Megadetector, which resulted in more than 15 million images of individual animals. This became the training dataset for our large base model. After extensive experimentation with 5 different model architectures, we settled on a ConvNext v2 model architecture. Our final base model was trained to accept areas of images with animals identified by Megadetector and can predict 178 different taxa, covering a wide range of species diversity to be a good general backbone for building custom models. We then ran fine-tuning experiments with data from a few initial partners to assess the performance of the base model when tuned on new habitats and species. The fine-tuning resulted in models that trained quickly and were generally accurate for new tasks. This work is now freely and openly available in our Python package Zamba and in our web interface Zamba Cloud. The Python library supports image prediction and fine-tuning and has robust documentation and user tutorials to demonstrate the use of our new image models. Zamba Cloud is the website that puts a simple, easy-to-use interface on top of our Zamba library. Zamba Cloud includes well-performing base models for many common use cases, easy ways to get predictions from those models, custom training of new models on your data with no code, fast video uploads for slow connections, image and video media management, cloud-based processing of models and data so you don't need fancy hardware, and no vendor lock-in because we use standard formats for everything and it is all easily downloadable. To see some examples of custom model training and species prediction workflows, visit our website to watch tutorials and demo videos. We didn't do this work alone. The WILDLABS community was incredibly helpful in shaping our approach to handling images. To make sure the tooling we built under this grant would best fulfill actual user needs, we reached out to the community with a camera trap survey. While many respondents collected videos with their camera traps, almost all collected still images. There were various approaches to processing that data, but manual review was still a big part of the process. And while folks are experimenting with lots of different tools, almost everyone highlighted their desire for custom species classification. We also ran 2 webinars on Zamba Cloud. One as part of the Charting the Future Wildlife Monitoring Towards 2030 Talk series, hosted by the Smithsonian Institution, Wildlife Conservation Society, and World Wildlife Fund, and one for the WildLabs Variety Hour. So far, feedback has been overwhelmingly positive, and we've been able to continue tweaking the platform to better support our users. I want to give a big thanks to all our collaborators and users that have provided terrific input and guided our process, and of course, everyone at ARM, WildLabs, and in the WildLabs community for making this work possible and sharing out Zamba Cloud. We hope it helps everyone move their work forward, and we're excited to keep building out the tools that support the community.